Okay, so I will take this class for half an hour. Okay, this class I will take for half an hour. Okay, so let us start the problem. Yeah, so this is our problem. I hope all of you can see it. Okay, so can you see the screen? All of you? All of you, can you see the screen? Yes, sir. Okay, okay. So this is the most important type of problem, which is our design of the section. Okay. So you see the question, calculate the area of tensile and compressive steel required for the following data. That means we have to find out the amount of steel. How much amount of steel we will provide in the tension zone and how much amount of steel we will provide in the compression zone, we have to find out from the given data. Okay. So in this question, your size of the beam is given 250 and 450 millimeter effective. That means the width of the beam is 250 and the effective depth is 450 mm. Okay, and the bending moment which is resisting by the beam is 65,000 Newton meter, and DC is 50 millimeter. DC is nothing but, in the previous problems we are indicating DC by D dash, D for effective cover and C for compression. Okay, so that means it is the effective cover for the compression reinforcement. Okay, or it is our D dash. Okay, so it is also given that we are using M20 grade of concrete and Fe415 steel. Okay, so let us see how we can solve the problem. So whenever a problem is given to you, always your first step will be to write down the given datas. Okay, so the given datas are, you can see the given datas. B is given, effective depth D small d is given, bending moment is given, D dash is given, then for M20 grade of concrete, sigma CBC is 7, and for Fe415, sigma ST equal to 230 from table number 22. Okay, so next in this question, okay, in this question we have to find out J, K, everything we have to find out. Okay, so first find out the design constants K, J and R. Okay, so we know that M equal to 280 divided by 3 sigma CBC. So we have got the value 13.33. Then from the value of M, you can find out the value of K. K is M into sigma CBC. This formula is for K. So you put all the values, you will get the value of K. From the value of K, we know that J equal to 1 minus K by 3. Okay, so you simplify it and solve the problem, you will get J value equal to 0.9. Then we know that R equal to half sigma CBC K into J. Okay, so R equal to, find out the values, sigma CBC, put the values, K, put the value, you put all the values, you will get the value of R. Okay, so now we know that the depth of neutral axis equal to K into D, and this formula I have given you in the first class of this semester when I have shared the first PDF. In the first PDF I have given you this formula. Okay, N equal to KD. Right? So put the value of K, put the value of D, you will get the value of actual neutral axis. Okay, then since it is a doubly reinforced beam, we know that our moment of resistance will be consisting of two types of moments, M1 and M2. Okay, so you can see here moment of resistance of a balanced section equal to M1. Okay, M1 equal to, we know the formula RBD square. So put the value of R, this is the value of R 0.91, put the value of B which is 250 and put the value of D which is 450, which is given. Okay, so if you put all the values, you will get a value of M1. Okay, you put the value of, you will get the value of M1. So M1 they have got 65 kilonewton meter. Okay, so now we know that the total moment is equal to M1 plus M2. Okay, see in the question the total moment is resisting by the beam is given 65,000 Newton meter. And we know after calculating we have got that for a balance section the moment of resistance equal to how much we have got 65. Okay, so how much additional moment we have to resist? This minus this. Okay, yeah, m1 value is this one, m1 value is this one, 46 rbd square. If you put all the values it is 46 point something, 46.06. okay, and this is the total moment which the beam is resisting, total m, which is given in the question. So the extra moment how much we have to resist? Total moment minus moment resisting by a balanced section. Okay, the total moment minus m1. So this is the value given in our question. This one we have calculated, m1. This is the value. So if you deduct the value, we will get m2. m2 means this much additional moment we have to resist by providing additional reinforcement in the tension zone as well as in the compression zone. Okay, so now our aim is to find out AST and ASC, area of steel in compression, as well as area of steel in tension. Okay, so you see the formula here, area of steel in tension. Okay, area of steel in tension, you see here, first you see AST1. Okay, so you can see m1 divided by sigma st j into d. m1 is this much, sigma st value we know 230, j is 0.9, d is 450. Okay, okay, so what is the meaning of this? This means this amount of steel will be required for a balance section. Okay, this amount of steel will be required for a balance section. That's why you have seen that m1 is used. m1 is this one, moment of resistance for a balance section, m1. Okay, that means if you are using a balance section, this amount of steel will be required. Okay, but now we have to resist some extra amount of moment which is given by m2. This is the extra amount which we have to resist by providing some extra reinforcement. Okay, so for this amount of bending moment, how much steel we will require? It is given by this formula, AST2 equal to m2, this value, divided by sigma st into d minus d dash. Okay, so after putting all the values, you will get this is the value. Okay, so we have seen that for a balance section we need this amount of moment, this amount of steel, but in this case since we have to resist some extra amount of moment, that is 18.9312, this m2, so we need some extra amount of reinforcement. So how much we need, we can calculate by this formula. For this amount of moment we have to provide this amount of extra amount of steel. This amount of steel we need to provide extra to resist this amount of bending moment. Okay, so total area of steel in tension will be AST1 plus AST2. Okay, AST1 plus AST2. You can see here total area of steel equal to, you add the values, you will get the answer. Okay, next for area of compression, total area of steel in compression, ASC, we have one formula, m into AST2 d minus n divided by 1.5 times of m minus 1 n minus d dash. Okay, so this formula you will get. Okay, I will show you the formula from where you are getting this formula. I will show you the basic equation from which we are deriving this equation. In the notes it is given, see here, this is the equation we have to find out, we have to use to find out the area of steel. This is the equation, ASC equal to m into AST2 d minus n 1.5 times of m minus 1 n minus dc or d dash, same. Okay, because this ASC means whenever we have to resist extra amount of moment, so in that case only we will provide reinforcement in the compression zone. That's why in this case we will take m2. Okay, m2 you can see here in this equation. we are taking AST2, and this amount of steel we are providing for resisting this amount, this value. See this value. We are using this value because this is the amount of steel we are providing to resist this amount of moment, this M2 amount of moment. Okay, so we are using AST2 and not AST1. Okay, so M into AST2 D minus N 1.5 into M minus 1 N minus D dash. So all the values are given. So if you simplify it, you will get the answer of ASC, area of steel in compression. Okay, so all of you please go through the answer again. And if you have whatever doubt you have, you can ask me now. Whatever doubt you have, you can ask me now. I know this problem will be a little bit confusing because the previous problems are very easy. Only you have to use the formulas. But in this question, you have to use your logic. Okay, how to solve it, how to proceed it, you have to use your logic because in this question, we are designing the section. And you can ask me why we are not using the equation of actual neutral axis or critical neutral axis, because in those equations we need the value of AST and ASC. You can see the equations. You can see the equation. We have to use the value of AST. Okay, but in this problem, while designing a section, this value is unknown to us. We have to find out this value. So we can't use this equation. You can see here, for using this equation, we need the value of sigma ASC as well as AST. And both values are unknown in this equation. In this question, both values are unknown. Okay, so we can't use this equation. So we have to go to the basic equation which we have, n equal to kd. Okay, our final aim is to find out the depth of actual neutral axis. Okay, this is one formula. So for using this formula, we need the d value is directly given. We need the value of k. For finding out k, first we have to calculate the value of m. From m, you will get the value of k. Then you will find out the value of j. After getting the value of k and j, you can find out the value of r, which is half sigma CBC k into j. So this is the procedure by which we can design a section, because sigma st and sigma means AST and ASC both are unknown, and we have to calculate how much steel we will provide in the tension zone as well as how much steel we will provide in the compression zone. These things we have to calculate in this equation. Okay, in this problem we have to calculate this. That's why the type of problem here, you can see it is the design of the section. Okay, you see, go through the solution, and whatever doubt you have, you can ask me now. Whatever doubt you have, you can ask me now. Because the next problem is also will be similar to this. So if you understand this problem, then the next problem will be very much easier for you. But if you don't understand this, then you will find it difficult for the next problems. Hello, are you listening to me? If you have any doubt, please ask me. Otherwise, I will go to the next problem. If you are not responding anything, then I will assume that you are understanding everything, which is not possible. I know that. Okay. So if I am asking that if you have any doubt, whatever doubt you have, you ask me. I will try to clear it. Raju,
এৰিয়া অফ ষ্টিল টেনচন জোনত এইটো এৰিয়াটো ডায়ামিটাৰ হয় নে কেনেকে প্ৰভাইড কৰে?
বুজা নাই কি কৈছা?
যোনটো এৰিয়া অফ ষ্টিল টেনচন জোনত
হা
205.16 mm² এইটো কেনেকে প্ৰভাইড কৰে? ডায়াত প্ৰভাইড কৰে নে কি এইটো বুজা নাই।
ডাইৰেক্ট প্ৰভাইড কৰিব। এইটো দিছ ইজ দ্য টোটেল এৰিয়া অফ ষ্টিল। অ'কে, এৰিয়া অফ ষ্টিল অকল এইটো প্ৰভাইড নকৰিব নহয়, এই দুইটা এড কৰি পেলাই টোটেল এৰিয়া যোনটো হ'ব সেইটো টেনশ্যন জোনত আমি প্ৰভাইড কৰিম। দিছ AST-টো এইটো যোনটো 205.16 ওলাইছে, এইটো কিহৰ কাৰণে ওলাইছে? এইটো যে আমি এক্সট্ৰা এমাউণ্ট অফ মুভমেণ্ট যোনখিনি আমি ৰেজিষ্ট কৰিব লাগে, এই M2 এইখিনি ভেলুৰ কাৰণে আমি এক্সট্ৰা ইমান ষ্টিল আমি প্ৰভাইড কৰিব লাগিব, ঠিক আছে। কিন্তু টোটেল আমি টেনশ্যন জোনত আমি কিমান ৰেইনফৰ্চমেণ্ট দিম? 494.47 প্লাছ 205.16, এই টোটেল এমাউণ্টটো আমি একেলগে দিম। বেলেগ বেলেগকৈ ষ্টিল প্ৰভাইড নকৰোঁ আমি। এই টোটেল দুইটা এড কৰি পেলাই যোনটো পাম, কিমান এমাউণ্ট অফ ষ্টিল আমি প্ৰভাইড কৰিম টেনশ্যন জোনত, ঠিক আছে। আৰু আফটাৰ গেটিং দ্য এৰিয়া ইউ কেন চুজ দ্য ডায়মিটাৰ। ইয়ৰ ডায়মিটাৰ মে বি 16, ইয়ৰ ডায়মিটাৰ মে বি 20, বাট দিছ এমাউণ্ট অফ এৰিয়া ইউ মাষ্ট প্ৰভাইড, ঠিক আছে। হেল্ল' ৰাজু, ৰাজু,
বুজিলো ছাৰ, বুজিলো
অ'কে,
ছাৰ।
ঠিক আছে ঠিক আছে। টোটেল এৰিয়া পোৱাৰ পিছত তুমি ডায়মিটাৰটো চুজ কৰিলে হ'ল। 16 ল'ব পাৰা, 20 ল'ব পাৰা, কিন্তু 16 ল'লে তুমি এইটো ডিভাইড কৰি পেলাই কিমান নম্বৰৰ বাৰ ওলাব পাৰিবা নহয়।
টোটেল এৰিয়াটো হ'ব লাগে যিমান প্ৰভাইড কৰিলো।
হা হা হা, টোটেল আমাৰ ৰিকুৱাৰ্ড এৰিয়া ইজ 700.63, অ'কে। So 700.63. So you can choose any amount, any diameter. You can choose 16 mm diameter or 20 mm diameter. But we have to provide this amount of area. Okay? That is the main aim. We have to provide this amount of area to resist this amount of bending moment. That is the aim. Okay, so I hope all of you have understood this problem. So let us see the next problem. As no one is responding to anything, I hope all of you have understood this. Okay, you see this problem and you try to understand. Okay, see example 2.16 and see the solution exactly same with the last one. If you have any doubt again, you ask me again, ask me now. Go through the solution, and if you have any doubt, whatever doubt you have, you can write down in the chat box. I will try to explain. Hello. Do you understand this problem, all of you?
Sir,
Huh?
sir, it area of steel in tension যোনটো using 20 millimeter die bars আছে সেইডোখৰ বুজি পোৱা নাই।
Yeah, তুমি এইটো 16 ল'ব পাৰা, huh? 16 ল'ব পাৰা, no problem. You can use 16 also because this is the assumption only. You can take 16 also, you can take 20 also, you can take 25 also. Okay, but
Okay, sir.
area number of area to so area iman besi nohoy, only 1365. So if you use 16 mm, then I think number of bars will be more. You can use 16 mm also, huh? It is not compulsory that you have to use 20 only. You can use 20 mm diameter also. Number of bars, how can you find out number of bars? Total area divided by area of one bar. Okay, if you use 20 mm diameter bar, then area of A5 means area of one bar. Okay, pi by 4 d square. So this is the area of one bar of 20 mm diameter. Okay, so total area is 1365 and area of one bar is 314. So total number of bars, how many? This divided by this, you will get approximately 5. So we will provide 5 numbers of 20 mm diameter bars as tension steel. You can take 16 also. It is not compulsory that you have to provide 20. Okay, you can take 16 also. Okay, so I am getting M1 condition. Okay, M1, how much you have got? Is it correct, this value? I don't know whether this is correct or wrong. You check the value. Is it correct, M1? On M1, how D equal to 6502? Because it is not D, it is D square. RB D square, one chin. Therefore, D value is given how much D? Yeah, D is given 650. So 650 square. If you square 650, then you will get 6502 like that. Okay, I hope it is correct. Yeah, Likiwi is saying it is correct. Yeah, M1 is correct. Since M is greater than M1, therefore the beam is designed as doubly reinforced. Okay, so I hope all of you are understanding this one. AST1, whenever AST1 you will write, you have to provide, you have to use moment for a balance section. M1 is the moment for a balance section. Okay, and AST2, whenever you will write AST2, that means the amount of steel which you are providing for resisting the extra amount of moment. So how much extra moment you have to resist? Total moment minus balance moment. So total moment is given in our question, 185,000. It is given in the question. Yeah, 185,000. It is given in the question. Okay, so this amount of extra moment we have to resist. So for this amount of moment, whatever steel we have to provide, that will be written as AST2. Okay, so total area of steel in tension will be this AST1 plus AST2. So if you use 20 mm diameter bars, you will get approximately 5 numbers. If you use 16 mm, then this number will be more. I think it will be 6 or 7. Okay. So after getting the value of AST, same formula to find out the value of ASC also. You can use this formula for compressive steel. M into AST2. See here, in compression zone, you have got a very small area, 197.3. So in this case, if you use 20 mm diameter bars, okay, if you use 20 mm diameter bars, then you can't provide a single bar also. So always you have to use your common sense. Based on the value of area, you have to choose your diameter. Okay. In this case, your see area is very high, 1316.5. So you can choose either 20 or 16. But in this case, area is only 197.3. So if you choose 16 or 20 mm diameter bar here, you can't even provide 1 bar also. So we will choose a smaller diameter bar. Let us assume 12 mm dia bars. So if you choose 12 mm, then you are getting approximately 1.74, means we will provide 2 number of bars in the compression zone. Okay. So after getting these two values, what we have to do? We have to design the section. We have to draw the section. Okay, it is not here. I hope you can draw the diagram. Your diagram will be this one. I will show you how to draw the diagram. Whenever you are asked to design a section, so after finding out the number of bars, always you have to draw a diagram. Yeah, this diagram. So in place of this, we have got 5 number of bars. Is it 20 numbers, 20 diameter, 5 number of bars? Here you will place 5 dots. Okay, and you will write down here 5 numbers of 20 mm dia bars. And in this compression zone, you have got 2 number of 12 mm diameter bars. So you will draw 2 dots, not 3. This is just a simple diagram to explain, but in this problem we have got, in the tension zone we are providing, if you are choosing 20 millimeter dia bars, you have got 5 number of bars. So you will draw 5 dots like this, 1 2 3 4 5, and after drawing those, you will write here 5 numbers of 20 mm diameter bars. And similarly in the compression zone, you will draw 2 bars only, 1 2, not 3, in for this problem. Okay, for this problem you will draw 2, and here you will draw another bar which is 5. Okay, so here after drawing this 2, you will write here that these are 2 number of 12 mm diameter bars, and in place of B you write down the value, in place of D you write down the value. Okay, in place of D dash you write down the value. Okay, this way you have to draw. After designing a beam, you have to draw a simple sketch of the section. Okay, whenever you are asked to design a section, always after designing the section you have to draw a simple sketch. Okay, this will be our sketch. Here 5 dots will be there, here 2 dots will be there. One will be 5 number of 20 mm diameter bar, here it will be 2 numbers of 12 mm diameter bars. In place of B you write down the value, in place of D you write down the value, in place of D dash you write down the value, ASC equal to write down the value, AST write down the value. Okay, so that is the final solution. Okay, so after this class I will share this PDF with you, so all of you go through the PDF. Okay, after this class I am going to share the PDF with you. All of you go through the PDF, go through each and every problem. If you have any doubt, any kind of doubt, if you have any kind of doubt in these problems, you can always ask me, you can always call me, you can always text me, or in the next class also you can ask me. Okay, okay, so I hope you have understood whatever we have discussed today. Okay, and all of you have got the attendance, no need to worry for that. Okay, so now for today's class, it is over. Today's class is over, and I hope all of you have understood whatever we have discussed. Okay, so just after the class I will share the PDF with you. All of you go through it, and if you have any doubt you can always ask me. Okay, okay, thank you everyone for attending the class. I am closing the session now. Okay, thank you. Whenever you have some doubt, always you can ask me. Okay, thank you.